So let us suppose we are having this program. Okay, so in this program, let me just number the lines. This is line number 1, line number 2, line number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there may be some legal or illegal initializations of pointer. So here we are going to see what are the legal and what are the illegal initialization of pointers. Okay. Now in the line number 1, I am declaring x as a register variable. So here this x is a register variable, and its data type is integer number. Okay. Then in line number 2, we are having PTR. PTR is a pointer which is stored in the register. So this PTR is a pointer and it is stored in the register. So in C language, whenever we write this keyword register before this integer number, that means before this data type or variable declaration, that means this variable will be stored in registers. So we do it whenever we want to store some data type which is extensively used in our programs and which is used again and again. So because the registers are closest to the main to the CPU, therefore, and its speed is the fastest, so it takes less time to access the registers, right? So here I am doing the register int x. That means this x is stored in the register, right? But it does not guarantee that it is stored in the register because it is done by your compiler. So it does not guarantee that this variable x is stored in the register, but we have said that please store this variable x to the register. So if the space is available, then this C compiler is going to store this variable x into the register, otherwise it will not store this into the register. Okay. So into the next, now in the third statement, we are having a character a. That means this variable a is of type character. Okay. Then in the next statement, we are having an integer number which is integer variable which is red. So this red is of type integer. Okay. So it is of type, it is a pointer, integer pointer. Okay. And it is a character, a is a character and red is a integer number. Okay. So we have covered this line number 1, line number 2, line number 3, line number 4 and line number 5. Okay. Now in the line number 6, I am storing the address of a to this pointer 2. Okay. So this pointer to this a, okay, I think we have not covered this pointer 2. So this we are having a pointer 2. So this is PTR2 and this PTR2 is of type character pointer. Okay, that means it is going to store the address of a character, right? So whenever we store these addresses, so if I declare a pointer of type int, that means that pointer is only going to store the address of an integer number, integer variable. And if I declare a pointer of type character, that means that character is only going to store the address of a character variable. If I declare the variable type as float, a pointer type as float, that means that that pointer is only going to store the address of a floating number, floating point number or floating point variable. Okay. So, right. So in the next statement, I am saying PTR2 is equal to address of a. Okay. That means this address of a is now stored in this PTR2. Okay. Now let us suppose this address of a is 1000 and this address is now stored in the PTR2 and this is a valid thing. So because I am storing the address of a character into a character pointer, so this is valid. Okay. Now in the line number 7, we are having PTR1 is equal to address of red, right? That means this red is an integer number, right? This is an integer number, integer variable, right? And I'm storing this address of this integer variable into this pointer 1. So this PTR1, I think this is, we have done some mistake here. This is PTR1. PTR1 instead of PTR, it is PTR1. So this here in this line number 7, we are storing the address of red into PTR1, right? So let us suppose the address of red is 2000, which will now be stored in PTR1. That means it is stored, PTR1 is storing 2000. Okay. Now in the next line, we are saying ptr1 is equal to address of x, right? But this x is a register variable. So this x is a register variable. But we cannot, because registers are the fastest available memory, which is closest to the CPU. So there's no need to find the address of this of any register variable. So this kind of allocation is invalid because C does not allow you to take the address of a register variable and store it into a pointer. Okay, so if whenever you see this kind of allocation where you are storing the address of a register variable into a pointer, that means this is invalid. So you cannot do this. Okay. Now in the line number 9, we are saying ptr2 is equal to address of red, right? So this red is an integer variable and this ptr2 is a character pointer. So that means this character pointer is only going to point to a character variable, not an integer variable, right? So this is invalid because we cannot store the address of an integer variable into a character pointer. To store the address of an integer variable, you need an integer pointer. Okay. Now in the line number 10, we are doing ptr2 is equal to address of 30, right? And this 30 is a constant number. This is not a variable. So if this 30 would have been some other variable, then it is a valid declaration. But this 30 is not a variable here. This is just a number, right? And we cannot store an address of a number, right? So this declaration is also invalid. Now in the line number 11, here also we are storing the address of a number to this ptr1. Okay, so this is also invalid. Now in line number 12, we are having address of a plus 3, and a is a variable, but we are doing plus 3 with a, right? And this becomes an equation. This is an equation, and we cannot store the address of the equation to any pointer. So this is also invalid, right? So that means, what are the valid declarations? If you are having a character pointer, then you can store the address of a character. If you are having an integer pointer, then you can store the address of an integer, right? If you are having a floating point pointer, then you can store the address of a floating point number, but you cannot store the address of any register variable. You can, I'll just write it here, but you cannot do. You cannot do. So number 1 is you cannot store the address of a register variable. Okay. Second thing which you cannot do is you cannot store address of a integer variable to character, or character to integer, or floating point variable to integer pointer, or floating point variable to character pointer, and so on. That means you cannot store the address of cross variables. Okay, variables of two different types. Okay, and third is you cannot store the address of an equation. You cannot store address of an equation. And fourth is you cannot store the address of a constant number, like constant number like 40, 30 and so on, right? So these are all invalid things. Okay, now let us check more examples on pointers.